Welcome to Maths for All. I'm Aisling Flynn. This is Financial Maths 1.4 Compound Interest. Compound interest. When money is saved or invested, it can earn interest, so extra money. When money is borrowed, interest must be paid on it, so you pay back more than what you borrowed. To compound means to build up. For example, for savings, any interest earned in the first time period is added into the total and will earn interest along with the existing savings in the next time period, so the amount gets larger and larger. For money saved or investment interest is earned. This interest rate is given as AER, annual equivalent rate. So you'll be told your investment will earn interest at an AER of 4%, for example, and the percentage is given for the year. For money borrowed, interest payable is calculated. The interest rate is given as APR, annual percentage rate, so you can borrow money at an APR of 6%. Okay, so both are percentages, both rates, but AER is used for investments or savings and APR is used for borrowings or loans. So here's an example. €12,000 was invested at 8% per annum for 4 years. Calculate the final value of the investment. So we're going to go through this year by year first, so we see what's happening to the money, and afterwards we can find a quicker way of doing that. Okay, so let's take year 1. We must add 8% at the end of each year. We therefore end the year with 108% of what we started with. Okay, so again, whatever your preference is for working with percentages, you can use the fraction method. So €12,000 by 108% gives you €12,960. So you end up with more than what you started with, 8% more. You may also choose to calculate 8% and then add it on. So you would calculate 960 and you would add it to 12,000. That's fine. Or my preference here is for the decimal approach. We do €12,000 by 1.08. So 108% in decimal is 1.08, and you get more than what you started with. You get 12,960. So the same answer both ways. So for the next few steps, I'm sticking with the decimal way. Okay, so that's year 1. So the amount at the end of year 1 is the starting amount for year 2. So year 2, you'll start with 12,600 and add 8% or multiply by 108% and we get 13,996.80. So for money, we'll always use 2 decimal places. That accounts for the cent. Okay. Similarly, what you finish year 2 with is what you will start year 3 with. Okay. So this figure here that we ended year 2 with begins year 3, and again finding 108% now. Now we're above €15,000. Okay, so the money is compounding, it's getting larger and larger. And year 4, we start year 4 with the amount that we finished year 3 with. We find 108% of that. And so at the end of year 4, the investment comes to $16,325.87. So there we have it. After 4 years, the investment had increased to €16,325.87. Now, the total interest was. So some questions ask you for the final amount of the investment, and some ask you how much interest was earned. So make sure you read your questions carefully and answer the question that was asked for full marks. Okay, so to find the interest, we take our final amount and we subtract what we started with, 12,000. And in this example we get interest of €4,325.87. Okay, so summary of all of it. In short, we found 108% 4 times. So now we're going to look at neater ways we could have done this, or quicker ways. So we could have started with €12,000 and found 108% 4 times. So multiply by 108%, or 1.084 times. And you can try that on your calculator and you can see that you should get also the 16,325.87. Okay, now we can go better again. We are multiplying by the same number 4 times. We've learned before that you can use powers to write those in short. Okay, so we can multiply 12,000 by 1.08 to the power of 4, and this will also give us the same answer. Okay, so this brings us on to the compound interest formula, which makes use of powers. And here it is, and it's available in your formula and tables books that are provided in the exam. So f is the final value. So when you're calculating the final value, you put in p, which is the present value. You multiply it by 1 plus I, the interest rate, and this must be in decimal. Okay, we'll see it in an example in a moment. And t is the time, so however many years or months, if you're working in months. Okay, it goes up there. So here's our same example. €12,000 was borrowed at 8% per annum for 4 years. Calculate the final value. So we're looking for f. Okay, and it's equal to p is what we start with, or what we have now, 12,000. In the bracket it's 1 plus 0.08, so the interest rate was 8%. In decimal form it's 0.08, and if you wish you could instead do the addition in your head. You could type in 1.08, which is what we used on the previous slide. Okay, and we will get the same answer as expected, €16,325.87. So of course it is quickest to use the formula unless there is a change between the years. Okay, for example, if extra money was lodged into an account after say year 1 or year 2, or if money was taken out or withdrawn from an account. In these cases a year-by-year approach is needed. Okay, so you go back and do it 1 year at a time. Now some examples. €102,000 was borrowed at 8% for 4 years. Calculate the final value. Okay, so what I would do first would be to write down my formula for the examiner and start to gain attempt marks. Okay, the next step is to put in some numbers for the letters. So we're looking for the final value f. The present value, or what was borrowed right now, was 102,000. I'm going to add my interest to 1. Okay, so 1 plus I. Now here's I. That was P. Okay, it's 8%, or 8 over 100, or 0.08. So we had this on the previous example as well. Okay, now you can do on your calculator 1 plus 0.08, or you can put them together and do 1.08. Okay, the last thing we have to enter is the time, and in this example it's 4 years, so to the power of 4. So quite similar to the previous example. Okay, now I'm going to show you how to do that on the calculator. Okay, so there you saw the various functions that were used. So as much as you can type it in exactly as you've written it on the paper. Okay, and for this example we get a final value of 138,769 euros, and round to 2 decimal place for money, 87 cent. Next example. Find the amount to the nearest cent that needs to be invested at a rate of 5% to give 2,500 in 5 years' time. So let's take our time here. So this time we're asked to find the amount that needs to be invested. So we need to find out how much needs to be invested now. So this time we're looking for P. The interest rate, I, is here 5%, which is 0.05, to give 2,500 in 5 years' time. That's F. Okay, so we'll start as before by writing the formula. And 5 years, that's our T. Yeah. Okay, so now let's enter the figures that we do have. 2,500 equals P, we don't know that, 1 plus I, so 1 plus 0.05 is that, and we're going for 5 years this time. Okay, now we're asked to calculate for P. Alright, so we need P equals. Now this quantity, 1.05 to the power of 5, is multiplied by the P, so what we're going to do is we're going to divide both sides by that. So always remember your algebra. If you do something to the left of an equation, you must do the same to the right. So anything divided by itself, of course, is just 1. So this gives me the result. P is equal to 2,500 divided by 1.05 to the power of 5. Okay, now let me show you how I did that on the calculator. Okay, and the answer we get for P is €1,958, and rounding to 2 decimal places, is it closer to 81 cent or 82 cent? 82, because the next digit is 5. Okay, so there you have that. Alright, another example. Harry borrows 160,000 at 3%. At the end of year 1 he repays €20,000. The rate of interest is then lowered to 2%. How much will he owe at the end of the second year? Now the first thing I notice here is that he makes a repayment after 1 year. So we cannot use the formula for this one. Okay, we'll take it on a year by year basis. Okay, so let's take year 1. Okay, he must pay 3% interest on his 160,000, and that would be added on. So you can do it in stages, or you can find 103% like we were doing previously. So on the calculator, now count your zeros when you're doing large numbers. It's very easy to put 1 too many or 1 too little, so we have 4 zeros. Okay, and after that interest has been added in, he now owes at the end of year 1 164,800. Okay, so that's what happens. Now at the end of year 1, okay, he pays back 20,000. So paying back means he lessens his debt, or he reduces it. Take 20,000 from that, and we have 144,800. Okay, and that is what he will begin year 2 with. So like before, we carry it down. Now, interest will be building on that for the second year, but at a lesser rate this time. It tells us 2%. So multiply by 1.02 to get 102%. And now he owes 147,696 euros. Okay, so if there's any change throughout the duration, you have to take it a year by year basis. Okay, so Olivia invested 10,000 euros in a savings scheme for 6 years. At the end of the 6 years, she had 12,653 euro and 19 cent. What was the rate of interest? So same topic, different question. Let's take out the information. So she invested 10,000. That's what she started with now at the start of the question. That's P. For 6 years, that's T. At the end of the 6 years, she had 12,000 and something. That's the final amount. And what was the rate of interest? So we're asked to calculate I. Okay, so a bit different, but let's start as always writing down the formula. Okay, and let's continue by putting in values that we do know. So at this stage, you've passed the question, maybe got 4 out of 10 when you've done this. Okay, so I is in the bracket there. That is what we have to solve for. Okay, now don't forget all you've learned in algebra. Left equals right, same changes to both. We're going to try and isolate this bracket that has the I inside it to get closer to solving for it. So I'm going to divide both sides by 10,000. Okay, so anything divided by itself is 1. So on the right hand side you're left with the bracket to the power of 6. When you divide the 12,000 figure by 10,000, you get 1.265319. Okay, so how to proceed from here? So let me just take you aside there for a moment. If I asked you or told you that x squared was 16, what's x? Well, you tell me to get the square root of 16, which is 4. Or if I told you that a to the power of 3 was 27, what's a? You tell me to get the cubed root of 27, which is 3. So cubed root has a little number 3 there. Okay, so same in this example, we're trying to get at the bracket, so we just want the bracket itself, and to do that we're going to get the 6th root of this, of both sides, okay, which gives me the 6th root of this number here. Alright, now let's see how we do that on the calculator. Okay, so for the bracket we get a value that's equal to 1.039999. Okay, I could continue but I won't. Okay, equals 1 plus I. Alright, now we have a very simple equation there. To get I equals, I'm going to take 1 from both sides. Okay, and I get I equal to 0.039999. Now we were asked the interest rate. If you remember, things like 8% looked like 0.08, 5% looked like 0.05. So here we've got 3.9999 and it was recurring. Okay, equals I. That's a percentage. So let's call it 4%. Okay, now depreciation. So this is closely linked to compound interest, it's kind of like the reverse. Okay, depreciation is the loss in value of an asset over time. So an asset is something that a business owns, for example, vehicles or a piece of machinery, and often when they're bought new, after 1 year they're not worth so much because they've been used a lot. Okay, so their value decreases over time. The reduced balance method is when the value falls by a given percent each year. Okay, and here's the formula for depreciation. So I think you'll notice it's very similar to the compound interest formula. The only difference is 1 minus I. Okay, so it's falling by a percent each year. Okay, again, this is available in your formula and tables book. Okay, if accounting F, or the later value or the final value, is known as the net book value, or NBV, and it's used to write off the values of assets after time. So say a delivery company had a van, well, after driving it for 10 years it's pretty much worthless, so they can write it off. Okay, here's an example. How much will a 30,000 car be worth at the end of 5 years, given the depreciation rate of 20% per annum, reducing balance method? Okay, well, we know that. Okay, so the starting amount P is 30,000, the time is T, is 5 years, and the interest rate is 20%, or 20 over 100 is 0.2 or 0.20 if you prefer. Okay, so just like previous examples with the interest, we'll write down our formula first, and then we'll put in some numbers. Okay, so we're looking for F. P was 30,000. 1 minus. Now, it might be a little trickier to do the subtraction in your head, so we'll keep it separate, 1 and the I, and it was for 5 years. Okay, so you can type it exactly like you see it there into the calculator. Here's that done for you. Okay, and I just noticed that I left out a 0 in that particular example. I had 3,000 instead of 30, but that's all right. You can do it correctly, and the correct answer should be 9,083 euros and 40 cents. Okay. Now it's time for you to do that. Try your quiz and your written exercises. And here's your glossary with some of the terms used.